Hello everyone. In this video, I am explaining the concept of fitting of curves. See, when you have data which is of two or more variables, to know the best functional relationship between variables, fitting the various functions such as a straight line, parabola, then power curve, exponential curves into the data, then that can be used to estimate the values of the dependent variable for the specific value of the independent variable. Okay. This is named as fitting of curves. Means you have a set of data. There are data points. Means for one value of x, then there will be corresponding value of y. Okay. Then that data is represented using a particular function. Means you have to get the functional relationship between the data points. See, for example, this is how the data is spread. Okay, data points. Now you can represent the functional relationship between these data points in terms of a straight line, right? Like you have to represent the whole data set using y equal to f of x. That is how to represent it as a function, y equal to f of x. You can approximate these data points either using straight lines or a parabola of second degree or power curve or exponential curve based on what kind of function you require. See, for example, if I take a straight line, then there are different possibilities. I can fit the data using straight line. See, using these 2 points also, I can draw a straight line. Using these 2 points also, I can draw a straight line. Here, I can draw a straight line which contains maximum number of data points. Means you have to consider that function which is best fit to the data. I don't consider the first one here or this last one. Okay, because they include only 2 data points, that is not a best fit for the given data points. Whereas if you consider this is a best fit line. So in terms of a function, I can represent, now if I draw a line passing through these points, then you will get a straight line that is a best fit for the given data points. Then I will get a straight line is always represented as y equal to ax plus b. Then I get a functional relationship between x and y, where x is the independent variable and y is the dependent variable, and this kind of function represents the whole data now. And we have to consider that line, that straight line, which is best fit for the given data. That is called as fitting of curves. Curve may be a straight line, it can be a parabola, it can be a power curve. Based on our requirement, we are doing that. Let us see how to do that. That is done using principle of least squares. See, this is the principle of least squares. Here yi minus yi, this quantity should be made minimum to get the best fit. Okay, so if you are representing the given data as y equal to f of x, small letter yi is the observed value of y at xi, y capital yi is the estimated value of y obtained by the function, whatever approximated function we have. Then the difference gives you the error, or it is residual for yi. If you decrease the error or minimize the error, then you will get a best curve. Now if you take this line, see, this is the actual value and estimated value. If you calculate, if the difference comes out to be large, that means we can't take it as a best fit. Now if you consider this line, the difference between the data point, means actual value, and observed value, estimated value, then that comes out to be less for this. So if you take the sum, square of the sum minimum, then you will get the best fit. So the best fit is calculated using the principle of least squares. There is a derivation how to obtain it. I don't do that. I'll directly give you the formula how to fit a straight line into the data, how to fit a curve in, means parabola, into the data, and so on. Let us see how to get the normal equations for. Now first topic, fitting of straight line. How to fit a straight line into the given data. So any straight line has a standard form y equal to a plus bx, where a and b are constants which are to be determined, and these coefficients or constants are to be determined using the normal equations. And normal equations for a straight line are given by summation y equal to na plus b into summation of x, summation of xy equal to a into summation of x plus b into summation of x square. Okay. These two normal equations you have to remember for a given straight line. You have to take the general form of a straight line as y equal to a plus bx. Then you have to write the normal equations. So based on the normal equations, you have to write the columns. So first example, fit a straight line into this following data. So let us write the data points x and y. X is 6, 7, 8, 9 and 11. Y is 5, 4, 3, 2, 1. Then first write, let y equal to a plus bx be the straight line that represents the best fit for this given data. I have to calculate the value of a and b, the coefficients. Now, as per the formula, normal equations for straight line are summation y equal to n a plus b into summation x. N equal to how many data points here? 5. A I have to calculate, B I have to calculate, summation x and summation y. So here this is your x, sigma x means total of x, sigma y means total of y. Okay, next I need summation xy, which is equal to a into summation x plus b into summation of x square. Easy to remember the formula, na plus b into summation of x as it is. In the second equation, y gets multiplied by x and a into this sum comes first, next plus b into summation of x square. Okay. Here, therefore, as per the formula, I need summation of x, which I can obtain from here. Next, I want summation of x square, means I have to write a column corresponding to x square. Then I want summation of xy, so I need a column corresponding to xy. Okay, I need square of all this, x square, 6 square, 36, 7 square, 49, 8 square, 64, then 9 square, 81, 11 square, 121. Then I need the sum of all this, summation of x square. Then I need to multiply x and y. 6 5s are 30, 7 4s are 28, 24, 18 and 11. I need summation of x, y. This is equal. I need the values of all this. Then I have to substitute into these normal equations. Easy. The thing is, you have to remember the normal equations. So for straight line, then for second degree parabola, then power curve and so on. Okay. Now let us take all sums here by adding all the values. Now let us add all these values. That comes out to be 41. This is 15 and this is 351 and this is 111. Okay. Now let us substitute all these in the normal equation. So summation of y, where is it? Here. 15 equal to n is 5 into a, I don't know, plus b into summation of x, which is 41. Next, summation of xy, that is 111 equal to a into summation of x 41 plus b into summation of x square 351. Therefore, 5a plus 41b equal to 15. Then 41a plus 351b, which is equal to 111. Now these are the two simultaneous equations I obtained. Now I have to solve these two equations. To solve these two equations, let us multiply by 41 to this first equation and by 5 to the second equation, because coefficient of a here it is 41. So here 41, here it is 5. Therefore, you have to simplify it further. So that gives you, say, 205a plus 1681b equal to 615. Then second equation is 205a plus 1755b equal to 555. Simplify this, means here it is subtracting, change the sign. Okay, this cancels and you will get here 74b equal to minus 60. So b comes out to be minus 0.818. 0.8108. This is the value of coefficient B. Similarly, once you obtain B, you have to substitute the value of B in any one of these equations. Let me substitute here either the first one or second one. 5A plus 41. I am using this first one, into B is minus 0.8108 equal to 15. Okay, this directly first one you use. No need to multiply it with 41. Okay, so 5A equal to, so you have to simplify this. Okay, this is 15 plus 41 into 0.8108. So A comes out to be 9.6486. Therefore, I got the coefficient A and B. Therefore, now line of best fit is given by how we have taken the line y equal to A plus bx. Therefore, as per this form, A is 9.6486 plus B is minus 0.8108 into x. You can write y equal to x plus b also, but as we have taken as it as y equal to a plus bx, so finally you have to write it in that form only. This is how we fit a straight line into the given data. Now, next is how to fit a second degree parabola into the given data. So, I have to consider the equation of the parabola as y equal to a plus bx plus cx square. For a straight line, it was just a plus bx. That is linear. Now it is second degree, so power of x must be equal to 2a plus bx plus cx square. Let this be the second degree parabola. Now you have to write the normal equations of this. Same as before, summation of y equal to na plus b into summation of x plus c into summation of x square. You have this x square term extra in the first equation. There you had just na plus b into sigma x. Now as it is second degree parabola, therefore you have a plus c into sigma x square. Next, sigma xy. Multiply this y by x. Then you will get a into sigma x plus b into sigma x square plus c into sigma x cube. Then similarly sigma x square y. So up to x square, because highest degree is 2 here. In the previous case you had up to sigma xy because it was linear. Now sigma x square y equal to a into sigma x square plus b into sigma x cube plus c into sigma x power 4. Easy to remember. First constant, then linear, then degree 2. Then in the second equation 2, here linear, degree 2, degree 3. Then in the third equation, here it was linear. Now it is quadratic, cubic and biquadratic, like that. So these are the normal equations. You have to remember these equations while fitting a second degree parabola to any data. Say for example, fit a second degree parabola for the following data. So it is given here. Let us write x, y. X is 0, 1, 2, 3, 4. Y is 1, 3, 4, 5, 6. I need, as per the normal equations, first write let y equal to a plus bx plus cx square be the second degree polynomial. Second degree parabola. Second degree parabola. Therefore, its normal equations are, once you have to write all those normal equations, I won't write here once again. Already I have here summation of y equal to na plus b into sigma x plus sigma x square. So I need summation of x, that I will get here. Then here I'll get summation of y. Then what else is required from the formula? Then I want x square, then I want x cube, then x power 4, then xy is required, then x square y. These are the columns required. So you have to write accordingly. X square, 0 square 0, 1 square 1, 2 square 4, 3 square 9, 4 square 16. Then x cube, so 0 cube 0, 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64. Next, I want x to the power 4. This is 0, 1, then you have 16 here, then 81, then here 256. Then I want x into y. This is 0, 1 3 is a 3, 4 2 is a 8, 5 3 is a 15, 6 4 is a this value. 24 and then I want sum of all. Then x square into y, that is this column into y. 1 0 into 0 0, 3 1s 3, 4 4s 16, then 9 5s 45, 16 6 96. You have to add up all these values. So this gives a summation of x square, this is summation of x cube, this is summation of x power 4, this is sigma xy, this is sigma x square y. So see, this total sum is equal to 10. Summation of y is 19. Then summation of xy is it is 50. Then summation of x square y is 160. You can check by adding all the values. Summation of x power 4 is 354. Summation of x cube is 100, and summation of x square is 30. You have to substitute all these values into your normal equations. So here first equation, summation of y, that is 19 equal to n, how many data points? 5. 5a plus sigma x into b, that is 10b plus c into sigma x square, so that is 30c. Next, similarly, summation of xy. Summation of xy is 50 equal to a into sigma x, 10a plus b into sigma x square, 30b plus c into sigma x cube, 100c. Next, sigma x square y, that is 160 equal to a into sigma x square, 30a plus b into sigma x cube, 100b plus c into sigma x power 4, 354c. So these are the three equations. Now we have to solve these three equations. Now these are the three equations, first equation, second equation and third equation. Now I'll multiply the first equation by 2. Then I'll get 38 equal to 10a plus 20b plus 60c. This is the fourth equation by multiplying the first equation by 2. Now you have to simplify fourth and second equation, because 10a you can cancel out. 10a plus 30b plus 100c, which is equal to 50. Now subtract these two equations. So you will get here 12 equal to minus 10b, this is, and here it is minus 40, and here it is minus 12 equal to minus 10b minus 40c. So that is nothing but, you can simplify this, 10b plus 40c equal to 12. You keep it as equation 5. Now further simplification. Now you have to multiply the second equation by 3. Therefore you will get 53, that is 150, which is equal to 30a plus 90b plus 300 into c, multiplying the second equation by 3. Now subtracting this equation, new equation, that is a sixth equation, subtract this sixth equation from this third equation. Okay. Why I have done like this? Because here you have 30a. So therefore you will get 30a plus 100b plus 354c, which is equal to 160, third equation. And sixth equation is 30a plus 90b plus 300c equal to 150. Subtract these two equations. This is plus minus, change the sign, this is plus, so this cancels. You will get a 10b here, 54c, which is equal to 10. Okay. So name this as equation 7. Now we have to solve this two variable equation. Here we have fifth equation, so 10b plus 40c equal to 12. This is the fifth equation, and this is the seventh equation. You have to solve fifth and seventh equations. So what you will get, this is 10b plus 40c equal to 12, and here 10b plus 54c equal to 10. So subtract, so plus into minus, so this gives you minus 14c equal to 2. So c equal to minus 1 by 7. Okay, that is nothing but minus 0.1429. I got the value of the coefficient c. Next, similarly, you have to get the value of those constants a and b. Substitute in any one of the equations. So here, if you substitute in any one of these equations, then see, I'll substitute here 10 equal to this. 10 into B, I don't know, plus 54 into C, just now I got 1429. So this is nothing but 10 equal to 10B minus 7.7166. So this implies B equal to simplified 1.7717. So that is, here this term has to be taken to the left hand side. 10 plus this value, then divided by 10 gives you the value of B. Now substituting B and C in any of the equations, earlier equations you have, you can take the first equation as well. So I will substitute in the first equation, that is this one. So I will write here 19 equal to 5a plus 10 into 1.7717 plus minus 0.1429. So this was the first equation. So into 30. Okay. This was the first equation, 19 equal to 5a plus 10b plus 30 into c. So a value I don't know, b value I substituted, 30 into c value I have substituted. Now I have to simplify all these. So after simplifying all this, 19 equal to 5a plus 17.717 minus 4.287. That gives you a equal to 1.114. So after getting the value of A, B and C, therefore the second degree parabola of best fit is second degree parabola of best fit is y equal to a plus bx plus cx square. So substitute accordingly. 1.114 plus b is 1.7717x minus plus c is negative minus 0.1429 into x square. So this is the parabola of second degree which best fits the given data. This is how we fit a second degree parabola into given data. Easy. You have to remember the normal equations for parabola. Similarly, in the earlier case, normal equations for straight line. Now next section is how to fit a power curve. Power curve is of the form y equal to ax to the power b. Variable raised to the power some constant value. So here a and b are the coefficients which are to be determined, constants to be determined. So normal equations of power curve are given by summation sigma u equal to NA plus B into sigma B and sigma UV equal to A into sigma B plus B into sigma B square. Almost same as the equations of the straight line. Instead of x and y, we are using now u and v, and capital A we are using here instead of a small letter a, because small letter a already used here. Okay. So here u equal to log of y to the base 10. U means log of y to the base 10. We are using logarithm to the base 10, not natural logarithm. Natural logarithm in calculator you can see it is denoted as ln. Okay, log means it is to the base 10. So u is log of y to the base 10, b is log of x to the base 10, and a is log of a to the base 10. So this is how to determine the values. So first you have to write the normal equations, then determine all of these one by one. So let us fit power curve y equal to ax to the power b for the following data. So first write x, then y. X is 6, 2, 10, 5, 8. Y is 9, 11, 12, 8 and 7. Now, as per the formula, let you have to take y equal to ax power b, a power curve and its normal equations are therefore these are the summation u equal to NA plus B into sigma V, then sigma uv equal to A into sigma V plus B into sigma V square. So where u equal to log of y to the base 10 and V equal to log of x and A equal to log of A. Okay, let us determine this as per the formula. By looking at the formula, we have to write the columns. So what is u? U is log of y. Then I want the column V, which is log of x. Okay, then I want as per this uv. Then it's a sum I want uv. Then I want v square. Okay, then I want v square. These are the columns. Columns are written based on the normal equation. So u equal to log of y. Log to the base 10, use the calculator, scientific calculator, and find out log of 9 to the base 10. Don't use ln. Either you can use log table or you can use the calculator. Directly you can use calculator. So log of y, log of 9 to the base 10 it is. So log of 9 is 0.9542. You can check with that. Then log of 11, 1.0414. Then log of 12, 1.0792. Then log of 8, 0.9031. Then log of 7, log of 8 over log of 7, last one. It is 0.8451. Okay. Next, I want V, log of x. So log of 6, first one, 0.7782. This is 0.7782. Then log of 2 is 0.3010 and this is 1.0001 it is. Log of 10, 10 to the base 10 it is. That's why it is 1. Anything to the any quantity to the same base is always equal to 1. Log of 5 to the base 10, that is 0.6990. Then log of 8 to the base 10, which is 0.9031. Then I want u into v, this product. So that is 0.7425. I'll write v square here. Then this is 0.3135. Then this is 1.0792. Then this is 0.6312. Then 0.7632. U into v. These two you have to multiply. Then v square, the square of this, that gives you 0.6055. This is 0.0906, 1.0000. Then 1 square is that itself. Then 0.6990 whole square, that is 0.4886. Then 0.9031 square, which gives you 0.8156. I need the sum of all these now. I don't want summation of x and y. I need sum of u, summation of v, then summation of uv, then summation of v square. Summation of u is 4.8230. You can check with that. This is 3.6813. Summation uv is 3.5296. Then summation of v square is 3.0003. Okay, substitute all these values into your normal equations. So we will get, I'll write here 4.8230 equal to 5a plus 3.6813b. The first equation I have substituted. Then similarly into the second equation, sigma uv is 3.5296 equal to 3.6813a plus 3.0003 into b. These are the two equations you obtain. You have to solve these two equations. So based on the coefficients, multiply this equation by 3.6813 and this equation by 5. Okay, because here coefficient is 5 and here coefficient 3.6813. Then you have to simplify. So what you get here is 17.7549 equal to 18.4065a plus 13.5519b into b, that I'll write here. Then similarly, next this equation becomes, after multiplying by 5, you will get 17.6480 equal to 18.4065a plus 15.00 15 into b. You have to subtract now. Okay, plus minus, this is minus. So, and simplify. You will get b as 0.0737 with a minus sign. So b is minus 0.0737. Once you obtain the value of b, you have to substitute it in any of the equation to get the value of a. A comes out to 1.0216. You check with that. Okay. Then a is, what is this a? Log of a to the base 10. Okay. A equal to log of a to the base 10. We need a small letter a. So a equal to anti-log of 1.0216. So which is equal to 10.5099. So A is 10.5099. B is this value. Therefore, curve or the power curve of best fit for the given data is given by y equal to 10.5099 into x to the power b is minus 0.0737. So this is the required curve. And here, to get value of a, we found anti-log of. Anti-log of means you have to find out 10 to the power 1.0216. That gives you the value 10.5099. If it is natural logarithm, then it is e to the power. Inverse of logarithmic function is exponential function. So e to the power. But here this is logarithmic function to the base 10. Therefore, it is anti-log of this value, means you have to find out in the calculator 10 to the power 1.0216. That gives you 10.5099. Now the last section is fitting of exponential curve. What is the standard form of exponential curve? Y equal to a into b to the power x, be the exponential curve. In the power curve, you have a into x to the power b, some function, some variable to the power constant. But now here constant, its power is a variable. That is the difference between exponential curve and power curve. Okay. So now normal equations for this exponential curve are same as before. Summation of u equal to na plus b into summation of x. Here summation of ux equal to a into sigma x plus b into sigma x square. Instead of b, we are using x itself, and instead of small b, we are using here capital B. Okay, where a is given by antilog of a and b is antilog of the constant b value. Okay, now fit an exponential curve of the type y equal to a b power x for the following data. Let us see how to do that. Let us write now x and y. X is 1, 2, 3, 4, 5. Y is 8, 15, 33, 65 and 130. Okay. We want as per the equations normally. First write, let y equal to a b power x be an exponential curve. Then normal equations are, you write the normal equations. Then as per the normal equations, we need some sigma x. Then we need sigma x square, means we need the column x square. Then I want u. Okay, u is nothing but as before, u equal to log of y. Okay, so u equal to log y. So find out log y to the base, it is 10 again. Okay, so log of 8, so that gives you 0.9031, and here it is 1.1762, 1.5185, 1.8129, then 2.1139. Then I want sigma u into x. So u into x, this column, third and the first column. So it is 0.9031, 1.1762 into 2. So which gives you 2.3522, and here 4.5555. Next 7.2517, then 10.5697. Next I want x square. So 1, 4, 9, 16 and 25. 1 square, 2 square, 3 square, 4 square, 5 square. Then I want sum. Here all these sum. Sigma x also I want, which is 15. Sigma u equal to 7.5246. Sigma ux equal to 25.6322. Sigma x square equal to 55. Okay, substitute all these into these normal equations. So you will get here, this is first equation, 7.5246 equal to 5 into a. N is 5. 1, 2, 3, 4, 5 data points here. 5a plus 15b. Then 25.6322 equal to 15a plus 55b. You have to solve these equations as before. So one of the equations to be multiplied with the 15, another with the this with 15, this with 5, and simplify. Okay, I don't do it once again, and you will get b value as minus 0.3058, and a value comes out to be 2.4224. Okay, but we want small letter and small letter b, so a equal to anti-log of 2.4224, which is nothing but 10 to the power 2.4224. That gives you small letter a equal to 264.5087. Similarly, b comes out to be antilog of this value, which is 10 to the power, that comes out to be 0.4494. 0.4494. 10 to the power, though it is negative value, 1 by 10 to the, it becomes positive. So a value and b value I got. It is b, how to get? Antilog of minus 0.3058, which is nothing but 10 to the power minus 0.3058, which is nothing but 1 by 10 to the power 0.3058. First calculate this, then 1 by this value, it becomes positive, and it is 0.4494. Therefore, the exponential curve of best fit for the given data is y equal to a is 264.5087 into b is 0.4494 to the power x. This is the required exponential curve. So now let me summarize this. Fitting of curves is nothing but for the given data, the data must be of two or more variables. You have to get a functional relationship between the given data. That is, you have to get y equal to a function of x, so that when you have some independent variable value, then you will get the corresponding dependent variables value. So that is called as fitting of curves. Curves used here can be either straight lines or parabola or power curve or exponential curve based on our requirement. So fitting of curves is nothing but to the given data we have to fit a curve. Okay, that is nothing but it represents the functional relationship between the data points. And fitting of curves, the best fit is obtained using principle of least squares. Now in fitting of straight lines, we will take the equation of a straight line as y equal to a plus bx. It is linear. Power of x is equal to 1, highest power of x. You have to remember normal equations. See, you can also do this easily just by reading the book. But the thing is, you have to remember, or in some of the cases, like in exponential curve or power curve, log we have taken, antilog means 10 to the power. Okay, those things you have to remember. Here, get the normal equations, write the normal equations. You have to memorize these normal equations, no other option. So based on the normal equations, you have to write the corresponding columns of this table. Okay. Then you will get simultaneous equations. Solving those simultaneous equations gives you the line of best fit. That is fitting a straight line for the given data. Okay, now for fitting second degree parabola, same as before, but now degree of highest power of x is 2, a plus bx plus cx square. It's normal equations. Here you will get three set of normal equations because it is a quadratic. Okay, so y, then x into y, then x square into y. Remember it is easy. Constant sigma x square. Then in the next constant is replaced by sigma x, then x square, then x cube, then x square, x cube, x power 4. So based on these normal equations, write the corresponding columns, then get the equations. After substituting all in these equations, you will get three simultaneous equations. Solve one by one, that is any two first, that gives you third equation, then any other two next. You will get two equations in two variables. That helps you to find out the third variable, then using that second variable, then come back to the first variable. This is how we do in fitting of second degree parabola. Next, power curve is of the form a into x to the power b. Its normal equations are given like this. You have to remember what is u, what is v. Log of y is u, log of x is v. Okay, u first means, but it is y. For v next, it is x. Okay. Then a is log of a to the base 10. Here log is taken to the base 10. So in the calculator you have to use log, that's button. Log, but ln means natural logarithm. Then finally when you are calculating anti-log, it is 10 to the power this value. Next, last one is fitting of exponential curve. First, remember how the exponential curve is. It is constant to the power, the variable. That is how exponential curve is. Then write its normal equation. Based on the normal equations, look at the terms of the normal equation and write the columns accordingly. Here, though I have not specified u, here u is log of y to the base 10. Okay. Then as per the terms, substitute in the normal equation, you will get the values of the constants a and b. Substitute back into the standard form of exponential curve, you will get the best exponential fit for the given data. I hope you understood the concept of fitting of curves. If you like my videos, please share and subscribe to my channel. Thank you for watching.